This video is called Special Cases of Binomials, and the goal is I can find the square of a binomial and I can find the product of a sum and difference. So first, let's start with some review exercises. The directions state find the simplified form of each expression. So for number 1, I'm going to distribute. So I have 9y cubed times 2x squared y cubed. So 9 times 2 is 18. I don't have any x squared terms to combine it with any other one, so I just have x squared. And then y cubed times y cubed is y to the 6. For my next term, I have 9y cubed times 8x, so 9 times 8 is a positive 72. And then again, there's nothing to combine with the x, so I'm going to write x, and nothing to combine with the y cubed, so I have y cubed. For our last term, I have 9y cubed times a negative 5. So 9 times a negative 5 is a negative 45, and then we have y cubed. Number 2, for this one I'm going to multiply these two binomials. I'm going to do it using the distributive way with the arrows. If you'd rather draw a box and use the box method, you can also do that. So first I'm going to multiply 3a by everything in the second set of parentheses. So I have 3a times 2a is 6a squared. 3a times a positive 7 is a positive 21a. Now I'm going to multiply negative 5 by everything in the second set of parentheses. So negative 5 times 2a is a negative 10a. And then negative 5 times 7 is a negative 35. Now I see that I can combine like terms right here. I can combine those two a terms. So first I'm going to rewrite 6a squared. Positive 21 minus 10 is 11. So a positive 11a. And then I'm going to bring down the negative 35. So I have 6a squared plus 11a minus 35. Now let's talk about some examples of special cases of binomials. So looking at the first problem, the directions state find the simplified form of each expression. So for number 1, we have n minus 7 squared. First, let's talk about this. If I asked you, what does x squared mean? You would tell me this means x times an x. So when I have n minus 7 squared, what this means is n minus 7 times n minus 7. Now this looks exactly like what you just did. So let's go ahead and solve this problem now. So we have n times n, which is n squared. N times a negative 7 is a negative 7n. And now I'm going to move to the second number, which is a negative 7, and multiply that by everything in the second set of parentheses. So negative 7 times n is a negative 7n. And negative 7 times a negative 7 is a positive 49. Now I'm going to simplify this expression by combining like terms. So I have a negative 7n and a negative 7n. So that becomes negative 14n. And then I'm going to bring down my n squared and my positive 49. So now my new expression is n squared minus 14n plus 49. Number 2, we have 2a plus b squared. So this means that I need to write it twice. So make sure you always write this twice. So 2a plus b times 2a plus b So first I'm going to distribute that 2a to everything in the second set of parentheses. So 2a times 2a is 4a squared, and 2a times b is just 2ab, so plus 2ab. Next, I'm going to distribute that b to everything in the second set of parentheses. So b times 2a is a positive 2ab. So I always want to write the number first and then go in alphabetical order. So that's why I wrote a, then b. And then b times b is b squared, so plus b squared. Next, I'm going to combine like terms. So I have a positive 2ab and a positive 2ab, so I'm going to combine those. So first let me write the 4a squared. And 2ab plus 2ab is a 4ab, so plus 4ab, and then bring down the plus b squared. So I have 4a squared plus 4ab plus b squared. For number 3, I'm going to show you the box method again. So I'm going to write the first binomial at the top. So I have z, and then a negative 5, and then z, and then a positive 5. When I multiply z times z, I get z squared. Z times a negative 5 is a negative 5z. Z times 5 is 5z. And a negative 5 times a positive 5 is a negative 25. Now I'm going to write this in standard form, so I'm going to start with the term with the biggest degree, which is z squared. Then I'm going to combine negative 5z and positive 5z, and that actually makes 0, so that cancels. And then we're left with minus 25. So our answer here is z squared minus 25. I'm going to use the box method again for number 4. So I'm going to put the first binomial at the top, so 4x and a positive 7y, and 4x minus 7y. 4x times 4x is 16x squared. 4x times 7y, well, 4 times 7 is 28, and then I'm going to write in alphabetical order, so I'm going to put the x and then the y. And then 4x times a negative 7y is a negative 28 xy. And then we have negative 7y times a positive 7y is a negative 49 y squared. Now when I write this, I'm going to write 16x squared first. And then I'm going to combine like terms 28xy and a negative 28xy. Those equal 0, so those cancel, and I'm left with minus 49y squared. As you can tell for number 3 and number 4, the binomials look the same. For number 3 is z minus 5 and z plus 5, except for one has a minus sign, one has a plus sign. And as you can tell, what always happens is that middle term goes away, and then you're left with the first term z squared and the last term negative 25. Same thing happened with number 4. We have 16x squared in the front, that middle term canceled, and then we have minus 49y squared at the end.